So on Wednesday, we have completed about the developing the project network and what are the things that you have to follow when you are developing a project network. So basically, we have discussed about activity on node approach and activity on arrow approach, right? So we have now completed 4 handouts up to now. So today I'm going to start the handout number 5. It is called as program evaluation review technique. So and you can shorten this word as PERT, right? So basically you have to understand what is the meaning of this program evaluation review technique, right? So in the project network, you have identified that there are several activities that we have to do when we are delivering a project, right? So there are some activities which we have to do beforehand, before starting another activity. So those activities we are calling it as preceding activity, right? So for each of these activity, we have assigned the question itself given us the days or time, the duration which is taken to complete each and every activity, right? But in a we are in a volatile environment also. All the things are changing. Therefore, therefore predicting an activity time cannot be done in a realistic manner. Therefore, we are not giving one time. We are giving some 3 times. So, for example, we are think that everything would be happen in a perfect manner, and all the things will happen in a good manner. All the things will go on well, right? And after having like this assumption, we are assuming that the optimistic time. So the meaning of the optimistic time means we are assuming that all the things will happen in a good way. All things will happen in well manner. So if we are having an optimistic scenario, we can predict the time as optimistic time. But the pessimistic, the complete difference of the optimistic time is the pessimistic time. So in the pessimistic time, we are assuming that all the things might be go wrong, and it may take more longer time with compared to the optimistic time. And there can be another time, we can call it as most likely time. So we are given the middle time between optimistic time and the pessimistic time, right? So in the previous lesson, we get only a one duration for a one particular activity. But in here, we are getting optimistic time, pessimistic time, as well as the most likely time, right? So assume each activity duration follows a probability distribution instead of being a single value. So you have to assume that each and every activity has a probability. Therefore, we cannot predict the one single value for an activity time. So as they are having some probability to occur or probability to go wrong something, so we are actually having 3 times. So instead of having one activity time, we are assuming that we are having optimistic time. It is denoted as TA, and pessimistic time TB, and most likely time TN. PERT uses 3 time estimate for each activity: optimistic, pessimistic, and most likely time to present activity duration. So in the previous lecture, we have only given one duration time for one activity. But according to this PERT program evaluation review technique, we are assuming that there can be some probability to occur some activity. There can be positive times, or there can be we are assuming that all the things will go well. Therefore, we are assuming an optimistic time. That is called as TA. And there can be sometime all the things might be go wrong. And we are assuming that if the things are go wrong, what is the maximum time that will take to complete one particular activity. So that is called as pessimistic time. And in the middle, we are having a most likely time as well. So activity and project frequency distribution. So when I'm discussing the example with you, you can understand this. So for a one particular activity, you can get a middle time or a most likely time, as well as pessimistic time and optimistic time. So for a one particular activity, if we are assuming that all the things are going well and we will meet all the deadlines, so we are getting a optimistic time. And in the middle of the time, also having a several time, or if all the things are go wrong, we will take a longer time to complete one activity. And for a project, we are getting a middle time. So you can understand those things when I'm explaining the question for you. Right, so the activity time calculation. So when you are getting like this 3 times, optimistic time, pessimistic time, and most likely time, you have to calculate the weighted average time that will take by one particular activity. For each and every activity, you have to calculate a weighted average activity time. So in calculating weighted average activity time, you have to use these equations. So TE denoted as weighted average activity time. For that, you have to take the optimistic activity time. So the optimistic activity time, we can denote it as it is A, right? So the meaning of that is 1 chance in 100 of completing the activity earlier under normal conditions. So optimistic people are always thinking that all the things will go well and they can meet the deadline and they can actually do the activity beforehand the deadline, right? And for M means most likely activity time, and that M should be multiplied it by the 4. And B means the pessimistic activity. So pessimistic activity means 1 chance in 100 of completing the activity later under normal condition. So how long it will take if we are later that activity. So they are pessimistic. So do you know the meaning of optimistic people and pessimistic people? So what is the meaning of optimistic? We are expecting that all things will happen in a good way. But the pessimistic people are always thinking that all the things will go wrong and there might be some wrong or failures will happen. Due to that, the time taken to complete a one particular activity will take a longer time. Right, so you have to take this A plus 4M plus B and you have to divide that by the 6. So why you are going to divide this by 6? So you can see in here also it means 1A, and we are having 4 here, and this B means 1B. So therefore you can see we want to get an average, right? 1, 4, 1 means the summation of that is equal to 6. Therefore, we are wanting to get a weighted average activity time. That's why we are divided by the 6, right? Did you get that? Hello? Can you hear me? Right. So that's why we are divided it by the 6, right? So this is the equation that you have to use when you are calculating a weighted average activity time. So according to this example, you are basically getting the optimistic time, pessimistic time, as well as most likely activity time. So the next one is, I have given you an example for you. There are some activities, as well as they are given the pessimistic time and most likely time, as well as the optimistic time. And they are asking to calculate the expected time for each of these activities. So did you all check the LMS? I have uploaded this PPT as well as the Excel sheet. I have uploaded that Excel sheet because it would be easier for me when explaining how to solve the question, right? And I have uploaded the cumulative distribution table as well, right? So I will now go to the Excel sheet. Right. So in this Excel sheet, so the same question, this question I have put it. I have actually copy paste for the Excel sheet, right? So can you all work with me, right? So we have now known how to calculate the weighted average activity time. So they are given as the optimistic time, most likely time, as well as the pessimistic time. So they are asking to calculate the weighted average activity time. So this is the equation that I have explained for you, right? So based on this equation, you have to calculate the weighted average activity time for each of these activities, right? So can you all take some piece of paper and work with me? Huh? So for activity A, I will calculate using the Excel, right? So activity A, first you have to get the what? You have to get the A. A means the optimistic time. The optimistic time for A activity is 2. So type that 2. So you have to write down that 2, and you have to add 4 into most likely time. 4 into, again, most likely time for the activity A is 4. So again 4 into 4, and you have to again add back the pessimistic time. Pessimistic time for the activity A, how much it is? 6. So you have to add that 6, and now you have to close the bracket, and you have to divide that whole thing. As we are getting a weighted average thing, you have to divide this by 6. So time taken, or the weighted average activity time for the A activity is 4. So likewise, you have to do for each and every activity. Up to K activity, you have to calculate the expected or the weighted average activity time. So did you all get that, how to calculate the weighted average activity time? Huh? Hello. So please calculate the weighted average activity time starting from B to K. So I will give you 2 minutes. I think that is enough. So try to calculate that in that quickly. So I will explain one more activities. First, you have to get the optimistic time for the B activity. It is 3, and you have to plus that and multiply it by the 4 into most likely time. It is 7. So multiply it by the 7, and again you have to add back the pessimistic time for the B activity. It is 10, and as we are getting a weighted average activity time, you have to divide the whole thing by 6. So for the activity B, you have get the amount as 6.83. So I have limited this thing for the 2 decimal place, right? I will limit this only for the 2 decimal place, right? And now you have to calculate these weighted average activity time for all these activities. So I will drag and what? So once you have finished this calculation, please let me know. Have you finished? Huh? Did you all calculate the weighted average activity time for each of these activities? So see whether you have got the similar answers in the Excel sheet. Right. So the next one is we have to calculate the standard deviation for the activity. So we have now calculated the weighted average activity time, and now we are wanting to calculate the standard deviation for the activity. So when you are going to calculate the standard deviation for the activity, you have to use this equation. So you have to take the pessimistic time. From that pessimistic time, you have to deduct the optimistic time and divide it by the C. So that is called as the standard deviation for the activity. And you can calculate the variance for the activity as well, right? So the for the standard deviation, after calculating this standard deviation, you have to take the power of 2 in order to calculate the variance of standard deviation, right? So this is the formula that you have to use when calculating the standard deviation for the activity. So if you are wanting to calculate the variance for the activity, you have to take this similar formula and take the power of 2, right? So try to calculate the standard deviation for each of these activity now by using this equation. So first you have to take the what do you call pessimistic time. From that pessimistic time you have to deduct the optimistic time, and you have to divide it by the 6. So I will go limit this to only 2 decimal, and I will drag and drop. So see whether you have take these standard deviation for each of these activities. So try to calculate using the calculators, because in the exam you have to do it by yourself. I am just typing the equation and get the answers through the Excel. So I will give you 1 minute to take the standard deviation. So once you finish calculating the standard deviation, please send me a test message. So I will explain the variance calculation as well. So after calculating this standard deviation, you have to take the power of 2. So after calculating this similar answer, you can take the power of 2. So simply get in the power of 2. And you can calculate the variance for each of these activities. So please do this calculation, standard deviation for each of these activity and variance calculation for each of these activities. Are you all working with me? Calculating these figures? මේ figures calculate කරනව නේද? තාම නිදි අයත් ඉන්නවද? So try to calculate those things by getting a lesser time, because we have to do lots of things. And actually, I want to cover this lesson by today. So once you have finished of calculating standard deviation and variance, please send a message quickly. So please do this calculation, because when I am moving from this lesson onwards, if you are not calculating those calculation, means you cannot progress this, right? That's why I am giving you time to calculate these things. So the one student said she or he is finished. So what about others? Another one is said he's also finished. One said is still doing. So shall I give you 2 more minutes to complete? Okay. I think most of you have finished it, right? So I will go for the next calculation, right? So according to this example, they didn't ask us to uh, draw a project network, right? And they didn't give any preceding activity. Therefore, we cannot draw that project network, right? So, therefore, we couldn't find the critical activities for this project network, right? We cannot find critical activities because they give only activity. They didn't give any preceding activity. Therefore, we couldn't draw the project network and couldn't find the critical activity. Therefore, for this question only, you have to assume that A, C, F, I, J, K. These are the critical activities. So, please make sure these activities, please highlight those activities. So if you have highlight those activity means it would be easier. A, C, F, A, C, F, I, J, K are the critical activity. So please, after identifying the critical activity, please make sure to highlight those activities. And please highlight those activities, and then so we have calculated the weighted average activity time and standard deviation for the each activity as well as the variance for the each activity. So now we are going to calculate the standard deviation for the project. So when you are going to calculate the standard deviation for the project, you have to take the summation of these uh, what do you call the weighted average activity time variance, right? So we have calculated the variance for each of these activity, but these activity, the variance of these activity need to be taken only for the critical activity. In here, the variance for the weighted average activity time, you have to take these only for the what? Only for the critical activity. So that's why I have asked you to highlight those activities. So after highlighting those activity, you can simply highlight the variance which is for the given activity. For the A activity, the variance is 0.44. And for the C activity, 0.25. So for the F activity, it is 1. And for the I, J, K, I have highlighted, right? So in this standard deviation for the project means you have to take the variance of the critical activities and get the square root. After getting the summation of the critical activities variances, you have to get the square root of that. Right. So can you calculate this and tell me the amount? Is this the value you taken? Or should it be different from this? 1.45. So I think 1.45, right? So it is when you are getting it by calculating only taking the 2 decimal, it is exactly 1.542, right? So did you all get this answer? Right. So Diane and the name I cannot read the other person. So get the 1.45. So what about others? Did you all get the 5.45 for the standard deviation for the project? So you have to simply take the variance of the critical activity, get the summation of the variance of critical activity and take the square root. So this is implying that you have to take the summation of the variance of the critical activity and get the square root out of that. Right. So I think the time is enough for you to calculate the standard deviation for the project. So please make a note this standard when you are calculating the standard deviation for the project. You have to take only the variances of the critical activity. In here, you have to take only the variance of the critical activity and take the summation of that. And out of that, you have to take the square root. So I didn't mention those things in the PPT PowerPoint. That's why I'm asking you to make some note, right? So remember that only the critical activity variances you have to take when you are getting the standard deviation for the project, right? So the next one I would like you to calculate is expected time of the project. So this is the standard deviation for the project. And next one I would like to calculate for you is, please calculate the expected time of the project. How you are going to calculate the expected time of the project? When you are, after drawing the project network, you have calculated the early start time, late start time. Likewise, you have calculated. So how to calculate the expected time for the project? You have to get the summation of the critical activity of the expected time. So the expected time summation, take the expected time summation of the critical activity. So that is also I'm going to highlight. Therefore, it would be easier for you to take the summation. So when I am asking you to calculate the expected time of the project, you have to take the one summation of the expected time of critical activities. So please make some notes, right? I didn't mention those things in the PPT. So when you are calculating the expected time of the project also, you have to take the summation of the expected time of critical activity. In here also, you have to take only the variance of the critical activity. So after calculating the expected time, can you tell me the answer? Did you all get this 21.3433? 21. Diane, I think it should be 21. I think you have at the tree, which I have highlighted previously for the H activity expected time. It is not a critical activity, therefore you cannot get that 21.34, right? So actually we are not telling like this way, right? 21.33 days that will take. Likewise, we are not going to tell. So after calculating this figure, so you have to calculate this figure and you have to give the roughly it is what? It is 22 days, right? දැන් අපි මේ 21.33 කියන එක ඔයගොල්ලෝ calculate කරන්න ඕනේ අනිවාර්යයෙන්ම. ඊට පස්සේ ඔයගොල්ලෝ ඒක මේ ඒ කියන්නේ roughly අපි 21.33 days යනවා කියන්නේ 22 days ගන්නවා කියන එකනේ. ඒකත් ඔයගොල්ලෝ පෙන්නන්න ඕනේ. roughly කියලා දාලා මේ 22 days කියලා. අපි roughly කියලා දාන්නේ. Right. So those are the things I want to calculate you for the example number 1. Right. So did you all make some note for the standard deviation for the project? You have to take only the critical activities of the variances and take the summation. And for the expected time of the project also, you have to take the expected time summation of the expected time of the critical activities, right? So please make some note. Yes. No. So this is one just an example for you, right? So in the next following example, I am asking you to draw the project network, right? So after drawing the project network, you are able to identify the critical activity, right? So in the exam paper, I will not give critical activity. I will ask you to draw the project network, and then after you can actually identify the critical activity. So Rukshika, did you get the answer for your question? Right. So we will move to the example number 2. So it is a little bit different. So example number 2. So in the PPT, we have now done this. In the PPT also it is mentioned that the standard deviation of the activities squared in this equation. This is also called variances. This sum includes only activities on the critical path or path being reviewed, right? This is also mentioned, but when you are making some calculation in here itself, please make some note so that would be easier for you to remember. So then after I am asking you to calculate expected time, standard deviation and variance. So now we have calculated those things for the example number 1. So this is the second example that I want to discuss with you. Right, so we will go to the Excel sheet. So in the Excel sheet, you have been given the activities. So from activity 1 to activity 2. Then after activity 2 to activity 3. Likewise, they are given, right? So actually, you have to draw a circle here, but drawing circle in the Excel and putting some numbering is difficult for me now. That's why I have that's why I have drawn what do you call a box for indicating 1. දැන් ඇත්තටම මේ වගේ activity 1 2 activity 2 3 එහෙම කියලා දුන්නාට පස්සේ ඔයගොල්ලෝ circle එකක් ඇඳලා යන්නම ලේසියි. එතකොට circle එක ගත්තොත් in the circle itself, you can divide that circle into 3. Right? you have to divide this circle into 3. You have to divide this circle into 3 and indicate the activity number in the above of the circle. And you can calculate the early start and late start time, right? So දැන් මේ වගේ එකක් දුන්නොත් ඔයගොල්ලෝ අනිවාර්යයෙන්ම circle එකකින් ඇඳ මේක ලේසි. හැබැයි මට මේ Excel එකේ circle ඇඳලා ඊට පස්සේ type කරන්න අමාරු හින්දා තමයි මම මේ box එකකින් ඒක indicate කරේ. Right? So when you are making this calculation, please make sure to draw these boxes as circle and please divide this circle into this way. So in the upper of the circle, you can indicate the activity name and then we can calculate early start and late start time, right? So in this example, you can see the activity 1 to 2, right? So I have drawn the activity 1. After completing activity 1, you can go for the activity 2. So the 1 to 2. And then the activity from activity 2 to 3. From activity 2 to 3. And then activity 2 to 4. Again, activity 2 to 4. Therefore, the arrow should come from activity 2 to 4. And next one is activity 3 to 4. So activity 3 is here. So activity 3 to 4. Sorry, 5. Activity 3 to 5. And next activity 4 to 5. So activity 4 is here. And after completing activity 4, you can go for the activity 5. And after completing activity 5, you can start to do the activity 6. So please make sure to draw these boxes in circles, right? මේ මම මේ boxes ඇන්දේ මට ලේසි හින්දා මේ කියන්නේ type කරන්න ලේසි හින්දා Excel එකේ ඔයගොල්ලෝ මේ paper එකේ මේව කරනකොට ඔයගොල්ලෝ note එක හදාගන්න කමන්නේ ඉන්නේ. එතකොට ඔයගොල්ලෝ circle එකකින් අන්න. So did you get how to draw the project network if you are getting like this activity 1 to 2, 2 to 3 likewise? So did you finish that drawing the project network? Right. So I think you have finished and you can see that they are given me optimistic time, most likely time, as well as the pessimistic time. So if you get like this question, first of all, you have to calculate the weighted average activity time. What is the expected time that would take to complete some of the activity, right? So how you are going to calculate the expected time? You know now the equation, right? So you have to take the optimistic time as well as you have to multiply it by the 4 into most likely time and again adding back pessimistic time and divide the whole thing by 6, right? So the expected time that would take to complete 1 to 2 activity is 30. Right, very good. So 30. So likewise, you have to calculate the expected time for each of these activities. So see whether you are getting the similar answers. So try calculate those things and see whether you are getting the similar answers for these. So once you have completed, please let me know. So one said finished. What about others? I think the time is enough. So after calculating the expected time for each of these activity, we have now drawn the project network as well. So these expected time, you can now put it in the above of the arrow, right? So for 1 to 2 activity, the expected time that will take is 30. So this 30, you can type it. So this 30, you can write down the above of the arrow. So the 30 will take, to complete 1 to 2 activity, it will take 30 times or days, right? And for 2 to 3 activity, it will take how many? It will take 30. Therefore, 2 to 3 activity, it will take 30. And so, can you see this, right? I think you can see. And for the 2 to 4 activity, it will take 20. So, for the 2 to 4 activity, it will take 20. And for the 3 to 5 activity, it will take 16 days. It will take 16 days, and 4 to 5 activity, it will take 6 days. It will take 6 days. So it's better to put these numbers in the above of that, right? And for the 5 to 6 activity, it will take 5 days. 5 days or 5 times. So did you all finish that? So after calculating the expected time, those expected time, you have to put it in the above of the arrow, right? So then after, you can now calculate the time expected, right? Finish. So expected time for the one activity, we know at the initial stage of the activity, that is 0. So for that 0, you have to add this 30, and early start time for the activity 2 is 30. So the things that we have done in the developing the project network, right? This 30 is going for the third activity as well. So when you are going for the third activity, you can see it will consume 13 days. Therefore, 30 plus 13, it is 43 days for the third activity. And for the fourth activity, it is 30 days taken for the second activity. And for that 30, you have to add the 20 as well. So after adding the 30 to 20, it is 50. So it is 50. And after going from the third activity to fifth activity, there are 2 arrows, right? So when you are having 2 arrows, you have to, as you are doing the forward pass calculation, you have to take what value? Lowest value or the highest value?
Highest value.
Yeah, thank you. So you have to take the highest value. So in here, 43 plus 16, it means 59 days. 43 plus 16 means it is 59 days. But here, 50 plus 6 means 56, right? Therefore, the between 59 and 56, the highest value is 59. So I have taken the highest value. And for that 59, you have to add this 5. So after adding the 5, it is what? It is 64. Right, so we have now completed the forward pass calculation. So this 64, you can put it as it is, as the late finish time, right? 64. So now we are going to do the backward pass calculation, right? From this 64, you have to deduct the 5. It means 59 here. And from that 59, you have to deduct 16. It is now 43 here. And from that 59, you have to deduct 6 to get the early finish time for the activity 4. It is 53. And in here you can see the activity 2 is a burst activity. So when you are doing actually the backward pass calculation, you have to take what value? Tell me what is the value that you are going to take for the activity 2? You have to take the lowest value. And what is the value you are taking here for the activity 2? Very good. It is 30, right? So from 43, you have to minus 13. It is 30. And from 53, you have to deduct 20. So it is 33. So among the 30 and 33, as we are doing the backward pass calculation, you have to take the lowest value. So that is 30. 30 here. And from that 30, you are deducting 30 again. So again 0 for the activity 1. So this is the way that you have to develop this project network and calculate the backward pass and forward pass calculation, right? So then after we can find what? So as the next step, we can find what? Now, right, very good. We can find the critical path now, right? So now we are going to find the critical path. So the things that is if we can easily find out, we can just connect the zeros like kite. So the place where the similar values are there. So the 0, 0 means 0 slash. So this is a critical activity. Activity 1. For the activity 2 also, it is similar, 30, 30. That means it is a critical activity. So I will make a different color. Color it is red. So from 30 to 30, 30. And for the third activity, you can see this is one of the critical activity. And this is activity 4 is not a critical activity because there is a slack time. And for this here also, it is also a critical activity. And this activity 6 is also a critical activity. So I have now colored the critical path as well. So after coloring the critical path, you can calculate the expected time of the project. You have to get the summation of the critical path activity and you can calculate the expected time of the project. So please calculate the expected time of the project. Hurry up. Expected time of the project means you have to take the duration, the summation of the duration of the critical activities. $64 days. Very good. So they are not giving it in days or like those things. So we are assuming that it would be days, right? So it is 64. So you have to take the from 1 to 2 activity, it is 30 days. 30 days plus from 2 to 3 activities, it is 13 days. And from third activity to fifth activity, it is 16 days. And from the fifth activity to sixth activity, it is 5 days. So you have to take the summation to calculate the expected time of the project. So the expected time of the project is 64. Right. So only the 2 people are actually sending me message. So what about others? Anita calculate කරනවද නැද්ද? So please calculate those things. Otherwise, you cannot progress this lesson. So that's why I am asking you to calculate. Please calculate likewise, right? Anita hadan ganda. Calculate karna. So do you want more time to calculate? So am I fast in calculating those things? Actually, I'm just using the Excel so I can quickly get those calculating. Right. So please calculate, okay? So I think you have now completed the calculation of the expected time of the project. So please make sure to actually make some note. These are the steps that we are following now. So up to here, what are the steps that we have followed first? So please make some notes, right? So when you are getting some this kind of questions, first you have to calculate what? First you have to calculate the expected time of the activity. So that is the thing we have done in the first, right? So after calculating the expected time of the project, you can draw the project network, right? So after drawing the project network, you can calculate early start and late finish time. So after drawing the project network, you have calculate the early start time and late finish time, and that is the third thing we have done. So the second one is draw the project network. Third one is calculate early start and late finish time. And the fourth step is find the critical activity, right? So find the critical activity, and after finding critical activity, you can take the summation of the critical activity duration and get the expected time of the project. So we have now completed up to that point. Right. So nextly, we are going to calculate the variance for each of these activities. So what is the equation you have to use when you are calculating the variance? So when you have to calculate variance, you have to, this is the standard deviation for the activity, and for the standard deviation, after calculating standard deviation of the activity, you have to take the power of 2 here. So after taking power of 2, you can take the variance for the activity. So that means variance for the activity is b minus a divided by 6 and take the power of 2. Right. So the variance now we are going to calculate. So please calculate the variances for each of these activities. So first you have to take b. From b minus a divided it by what? B minus a divided it by 6, and you have to take the power of 2. So this is for the variances. This is for the standard deviation. As we want to take the variances, you have to take the power of 2. No, Rashmi, it is not. You are telling that I have to deduct it by 6. Very good. So the value is what? 25 for the 25 for the variance. Rashmi, it is not the 5. It should be right. 25, right? So likewise, you have to calculate variances for each of these activities and see whether you are getting these answers. For the 1 to 2 activity, it is 25, 2 to 3, 9, right? So I will give you 1 minute. So after you finish, please let me know. One said, Hasini said, please explain that function again. right? So in here, we want to calculate the variance, right? So, so can you see this standard deviation for the activity? So when we are going to calculate the standard deviation for the activity, you have to take the pessimistic time. From that pessimistic time, you have to deduct the optimistic time OA and divided it by 6, right? This is for the standard deviation for the activity, right? So after getting the standard deviation for the activity, you can easily get the variance for the activity. So variance for the activity means you have to take B minus A divided it by 6 and take the power of 2. You have to get the power of 2. දැන් අපි standard deviation of the activity එක හෙව්වට පස්සේ ඒකේ වර්ගය ගන්න එක තමයි variance එක කියලා කියන්නේ. හරිද? Is that okay now? Hasini, is that okay? Right. So these are the variances that you have to get. 25, the one said 25, 9, 4, 1, 4, 1. Right? So up to this point, we have now completed. So the next one is I want to calculate you the standard deviation of the project. So can you remember the equation? So when I am asking you to calculate the standard deviation for the project, you have to use this equation. But please remember that I have asked you to make a note as well, right? When you are going to calculate standard deviation for the project, you have to take the variance of the critical activity, get the summation of all the variances of the critical activity and take the square root out of that, right? So please do and calculate the standard deviation of the project. So the next one I want you to calculate is standard deviation of project. 6. I think your answer is right, Diane. 6. So we will, I will also calculate that. So first you have to highlight the critical activity. So critical activities are 1, 2. I have highlighted that. So please highlight the critical activity, and 2, 3 also a critical activity. 3, 5 is a critical activity, and 5, 6 is a critical activity. So after highlighting the critical activity, you can take what? You have to take the variances. Variances also I highlight those things, and you have to take the summation of these things. You have to take what? You have to take the square root. Square root. You have to take the square root of the summation of all these variances. Right. The answer is right. The standard deviation for the project is 6. Did you all get this answer? Diane and Rukshika get the answer as 6. Right. I think most of you have taken the answer. That is the standard deviation of the project. Right. So that is all actually. So the next one I want you to calculate the probability of completing the project. So this slide we have now completed, and the next one I want you to do the probability of completing the project. The equation below is used to compute the Z value found in statistical table. So I have uploaded the cumulative values for the Z value. So Z number of standard deviation from the mean, which in turn tells the probability of completing the project in the time specified, right? So now we are going to calculate the probability of completing the project, right? That is the Z. And when you are going to calculate the probability of completing some activity, you have to take the critical path duration. You have to deduct the critical path duration from the scheduled product duration. Scheduled project duration is denoted as TS. From TS, you have to deduct the critical path duration, and you have to take what? This is what? The critical standard deviation of the project. Now, this is denoted the thing that we have divided is the standard deviation of the project. Then may probability of completing the project එකේදී අපි කරන්නේ critical schedule කරලා තියෙන project duration එකේ අපි critical path duration එක අඩු කරලා ඒ total value එකම අපි අනිවාර්යයෙන්ම බෙදන්න ඕනේ standard deviation of the project. Standard deviation of the project එකට අපි ගත්තේ variance එකේ variance වල critical path variance වල එකතුවේ square root එක තමයි අපි ගත්තේ standard deviation of the project. So this is the equation that you have to use when you are calculating probability of completing the project. So did you get that? Please remember that these equation I am not going to give in the exam paper, right? So you have to remember each of these equation. Did you understand what is the meaning of this equation? Right. So the network that we have drawn for this is explaining from the activity on arrow approach and activity on node approach as well. Right. So for this example, I will take the equation so I can explain it easily. Right. So in here, according to this example number 2, we have now calculated the critical path duration. So what is the expected time for this project is critical path duration is how many days? We are assuming that these are days, right? How many days that this project will take to complete critical path duration? According to this example, right? It is 64 days. So critical path duration for this project network is 64 days. That means T is equal to 64 days, right? And you have calculated the standard deviation of the project as well. So the standard deviation of the project, the things that you have to divide is 6. That is also we have calculated. So standard deviation of the project is we have calculated. It is also 6 now. Hence, you have to think that the scheduled time, TS, we are calling it as what? Scheduled project duration, TS. You have to assume that scheduled time for this project is 66 days, right? You have to assume that we are scheduling to complete this project by 66 days. But the critical path duration is 64 days. So, can you calculate the probability? So, you have to now calculate the effect. So, from the scheduled time of 66, You have to deduct the critical path duration, that is 64, and divided it by the standard deviation of the project. So standard deviation of that project is 6. So did you get this 0.33? I will limit this to the 4 decimal places. Did you get this value? Very good, 0.33. You get that, right? හැමෝම ගත්තද 0.33 value එක? Right. So this is not the end, right? We have now calculated the Z value. It is 0.33. So can you remember, I have uploaded the cumulative normal probability probability tables. So from here, you have to find what is the value for the 0.33. So in here you can see only the 2 decimal places are there. So please take the 2 decimal places. So I will make it as 2 decimal places. So it is 0.33. So in this table, you have to actually read out, right? So when you are reading the cumulative normal probability tables, you can see that we have get the value as 0.33. 0. We have to read this table from starting from left side. So 0.3 is here. 0.3 is here and 0.33. So the second decimal place is here. 0.3 here and 0.33 now. You have to go for the second decimal. So what is the value? So I cannot highlight this thing because it is a picture. So what is the value? 0.6293. Yeah, 0.6293. Take the whole figure, right? 0.6293. So 0.6293. That means if we are converting this to the percentage, it means 62.93%. Right? So did you get that? How you have to read this Z value using the table? So we want to complete this project. We want to complete this project using 66 days. But to complete this project within 66 days, there is a probability to complete that project within 66 days is 62.93%. That is the thing we have calculated here. So if the project manager is wanting to complete the project, the scheduled project by 66 days, there is a probability of completing that project within 66 days, that is 62.93%. That is the thing we have calculated now, right? So now please calculate if the schedule time is changed as 62 days. If the schedule time is changed as 62 days, what is the probability of finishing this project? What is the probability percentage of finishing this project? Calculate and tell me. So you have to first calculate the Z value, and after getting the Z value, you have to see from the table. After seeing from the table, you are getting a value, and that value can be converted into the percentage. Right? So first we have to calculate the Z value. First you have to get the schedule time. Schedule time is 62 days. From that 62, you have to deduct the critical path duration. It is 64 days. After deducting 64 days, you have to divide that whole thing by the standard deviation of the project. According to this example, it is 6. So you have now taken the value as 0.33. So as the table is given only the 2 decimal places, you have to take it for the 2 decimal places. Minus 0.33. So after finding this Z value, you have to you have to find out the value from this Z value table. So we want to get the minus 0.33. So this is for the positive values, right? This is the first table is for the positive value. And now we have taken a negative value. Therefore, you have to go for the next table. It is indicating the negative value. So the negative value, and the negative value we get is 0. I will make it little bit smaller, otherwise I cannot see the above of the table, right? We have taken the value as minus 0.33. So the minus is there, minus 0.3 is here, and minus 0.33. So what is the value? Minus 0.33 is 0.3707. Minus 3707. Minus 3707. So we can get the percentage. It is 37.07%. Yes. The schedule time I will give at the exam. Schedule time එක මම කියනවා. ඊට පස්සේ ඔයගොල්ලෝ expected critical path duration එක හොයලා ඒක calculate කරන්න තමයි තියෙන්නේ. So if you are getting the schedule time as 62 days to complete the project, there is a probability of completing that project within 62 days is 37.07%. ඒක තේරුණාද?
Oh, madam.
TS value එක ගන්න තැන ඉඳන් explain කරන්න. TS value එක මෙහෙමයි. දැන් අපි TS total දැන් අපිට ඕනේ ඊට පස්සේ probability එක හොයන්න. හරිද? එතකොට අපි මේ equation එක තමයි use කරන්නේ. Z value එක සමානයි TS minus TE. ඒක අපි බෙදනවා standard deviation of the project. එතකොට මේ TE කියන්නේ critical path එකේ duration. දැන් එතකොට අපි මේ question එකට අනුව TE එක හොයාගෙන ඉවරයි. ඒක කීයද? 64 days. ඊට පස්සේ ඔයගොල්ලන්ට calculation එක දෙනකොට අනිවාර්යයෙන්ම දෙනවා මේ වගේ schedule time එකක් යාවි. දැන් මේ අපි හදපු පළවෙනි එකේ schedule time එක මම කිව්වා 66 days ගන්නවා කියලා. එතකොට 66 days වලින් ඔයා critical path time එක 64 අඩු කරලා මේ standard deviation of the project එකෙන් බෙදුවම 6 යනවා. එතකොට z value එක අපි ගන්නවා 0.33. ඒ 0.33 එක අර මම upload කරපු cumulative normality probability එකෙන් හොයන්න. දැන් මෙතන positive 0.33 කියන්නේ positive නේ. එහෙනම් අපි positive table එකෙන් තමයි මුලින් බලන්නේ. එතකොට 0. මේ පැත්තෙන් තමයි start කරන්නේ left hand side එකෙන් 0.3 තියෙනවා. හරිද? 0. second decimal එක බලන්න ඕනේ අනිත් පැත්තේ. 0.3 හරි 0.33. ඒ කියන්නේ 0.6293. හරිද? 0.6293 ගත්තා. ඒක අපිට දැන් අපි කියන්නේ මෙන්න මෙච්චර probability එකක් යාවි අපිට මේ schedule කරපු 66 days වලින් complete කරන්න. ඒක ඊට පස්සේ අපි percentage එකට convert කරනවා. 62.93%. ඒ කියන්නේ අපිට දින 66කදී මේ project එක complete කරන්න නම් 62.93 වගේ 62.933යි percentage එකකින් කාලය කියන්නේ දින 66කදී ව්‍යාපෘතිය නිම කරන්න තියෙන probability එක තමයි 62.93% කියන්නේ. So, Rukshika, did you get the thing now? Huh? So as the second part, I have tell that the schedule time is now changed to 62 days. දැන් ඊට පස්සේ මම දෙවෙනි එකේදී කිව්වේ 62 days වෙනවා කියලා schedule time. එතකොට 62 days වෙනකොට TS එක විතරයි වෙනස් වෙන්නේ. TE එක එහෙමමයි critical path duration. ඊට පස්සෙත් අපි Z value එක හොයනවා. ඒ Z value එක ආවේ minus එක 0.33. ඊට පස්සේ minus 0.33 තියෙන තැන අපි හෙව්වා Z value එකෙන්. එතකොට මේ negative table එකෙන් තමයි ගන්න ඕනේ. එතකොට minus 0.33 minus මෙතන තියෙන්නේ 3 ඊපස්සේ 33 වෙනකන් යන්න ඕනේ. එතකොට 0. මේ 33 හරිද 0.3707 0.3707 එතකොට ඒක percentage එකකින් ගත්තම අපිට කියන්න පුළුවන් 62 days වලින් මේ project එක complete කරන්න අපිට 37.07% එකක් තියෙනවා. හරිද? Rukshika, is that okay now? Right. Another one is final interpretation එක exam එකට ලියන්න ඕනේද? Then I will ask you to calculate the Z value, right? And you have now calculated the Z value, right? After calculating this Z value, you can just tell that to complete this project within 66 days of the scheduled time, it will has a probability of 62.93, right? So you have to do up to this point, and if it is good, you can write down the interpretation as well, right? Is that okay? Hello. Right. So this is the one part, right? There is another thing that you can do. So if we are having a 95% probability, so in the first part of the calculation, we are calculating that how much of probability that will take to complete the project within the scheduled time of 66 days and 62 days. So this thing can be done in a reverse manner as well. So in the first part, we have calculated the percentage or the probability that will take to complete the project. So if they are given us the probability, if they are telling that there is a 95% probability to complete the project, so how much of scheduled time is needed to complete that project within 95% probability. අපිට මේ first එකේදී දුන්නේ schedule time එක 66 days වුණාම කොච්චර probability එකක් යාවිද කියලා අහුවාපෙන් මේක complete වෙනවා. හරිද? ඒ විදිහටම ඒකේ අනිත් පැත්තත් අපිට දෙන්න පුළුවන්. 95% probability එකකින් මේ project එක complete කරන්න ඔයාට කොච්චර schedule time එකක් අවශ්‍ය වෙනවද කියලා අහන්න පුළුවන්. Right? So that is the second part that you can get for your question. So assuming that there is a 95% probability to complete this project. So in here also, now you do not know about the TS, right? So if we are having 95% probability, that 95% probability, you have to figure it out from using this Z table, right? So from the Z table, 95% probability. So can you see this after I am zooming this Z table? Z table එක zoom කරාට පේනව නේද? Please reply quickly. So now I am asking what is the schedule time that will take if we are having a 95% probability, right? If you take the 95% probability, you have to find this 95% probability using this table, right? So see whether what is the place where 95% probability. Exactly. See whether if there is exactly value for the 95% probability? Madhushi said that 1.65. 1.65. Right. So Madhushi, can you see that it is 0.9505? Right. It is not exactly the 95%. Therefore, I will take the previous one as well. So it is 0.9495 and take the summation of the 0.64 plus 0.65 and divide that by the 2 to take an average. So 1.64 plus 1.65 divided it by the 2 means it is 1.645. Right. දැන් අපිට මෙතන 95% probability එක බලන්න ගියාම 95% probability එකම exactlyම නැහැනේ මෙතන. මෙතන දැන් 1.65 වල තියෙන්නේ 0.9505. ඊට පස්සේ 1.64 වල තියෙනවා 0.9495. ඒකින්ද අපි මේ දෙකේම එකතු අරගෙන දෙකෙන් බෙදලා average එකක් ගන්න. එතකොට 1.64 plus 1.65 divided it by the 2 means it is 1.645. ඒක තේරුණාද? Why we are getting the 1.645? අපිට 95% probability එක exactly මේ table එකේ නැති හින්දා අපි ඒකට දෙකට මැද තියෙන average එකක් ගන්න. 1.645 කියන්නේ. Did you get that? So I have taken this 1.64 plus 1.65. I will explain that. So you have to take the 1.64 plus 1.65 and take the average because we are not going to get the exact value for the 95. Therefore, you have to take the two values, get the summation and divided it by the 2. So it is 1.645. ඒක තේරුණාද මේ ඇයි 1.645 ගන්න කියන එක? ඒක ක්ලියර්ද නැද්ද? reply කරන්න නැති ක්ලියර් නැති නේද? දැන් අපිට 9 දැන් අපි මේකෙදි කරන්නේ 95% probability එකක් තියෙනකොට අපිට කොච්චර schedule time එකක් යාවිද කියලා තමයි අහන්නේ. හරිද? එතකොට 95% probability එක අපි හොයන්න ඕනේ පුතේ මේ z value table. හරිද? ඒකට 95% probability එක අපි exactlyම බැලුවම මෙතන නැහැ. 1.64 වල තියෙනවා 0.9495 1.65 වල තියෙනවා 0.9505. හරිද? ඒ කියන්නේ 95% exactlyම නැහැ. ඒකෙන් හින්දා අපි මේ ළඟ තියෙන values දෙකක, ඒ කියන්නේ 1.64 එකයි 1.65 එකයි දෙකම එකතු කරලා ඒක දෙකෙන් බෙදනවා. මොකද අපිට ඒකේ average එකක් ගන්න ඕනේ. අපි එතන හිතනවා 95% percentage එක ඇති කියලා. ඒක හින්දා තමයි මේ දෙකේ එකතු අරන් දෙකට බෙදන්නේ. I think now it is clear. The name is Manisha. Right. So now we have calculate this. Now we have know what is the Z value. So Z value is 1.645. So we know this value now, right? But we don't know the schedule time. So that is the thing we didn't know now, right? But the critical path expected value, we know that it is 64. So this is the unknown value. We know that 64 as well as we know the standard deviation. Standard deviation is 6. So now you have to solve this out and find what is the total schedule time. So you know the Z value, and from that after solving this you can take the schedule time. So please calculate this and tell me what is the schedule time for the 2 decimal places, and tell me approximately this much of days it will take to complete. ඒක solve කරන්න තියෙන්නේ. solve කරගන්න පුළුවන් නේද? What is the value you get? So approximately it is 74, right, Udara? Can you tell me this for the 2 decimal places as well? First, you have to tell that this is the value that we are getting for the 2 decimal place. Then after you can say that approximately 74, right? Rukshika said that it is 73.87. It should be 73.87, right? And then after approximately you can tell that it is 74, right? So in here you know the Z value and you know the standard deviation and you know the expected value that will take for the critical activity. Therefore, for the Z value is 1.645, right? From that you have to multiply this standard deviation. As we are dividing, you have to take the multiplication. So 1.645 multiplied by the 6 and add the expected value duration of the path, it is 64. So you are getting the answer as 73.87. So if we are making it as approximately, it is 74 days. So in the exam, please remember that you have to put it, you have to make it the calculation and get the answers and actually put it in the for the write it down for the 2 decimal places and then tell the approximately it will take 74, right? So that is for the 94. If we are having 95% probability to complete this project, it will take 74 days. Scheduled time is 74 days, right? So can you calculate this for the 99% probability? We are having 99% probability. How many days it will take as scheduled days? 99% probability එකක් තියෙනකොට කොච්චරක් days after scheduled days විදියට ගන්න ඕනද කියලා calculate කරලා කියන්න බලන්න. Hurry up and do. Calculate කරනව නේද? So I am giving you the time to calculate how much of scheduled days that will take if you are having a 99% probability. Right? So if you, as you are not answering, didn't you understand the things? How to calculate the scheduled days? Huh? Madhushani is telling that it will, Madhushi is telling that it will take approximately. Puta, you have to first mention it for the 2 days. Then after you have to tell that as it is approximately 78. I think it should be 77.95. Alright. So we will see, right? So when you are getting a 99% probability, first you have to see it from the table. So where is the place 99% probability? Quickly see the place. 99% probability. 99% probability is here. 2.32 to 2.33, right? You have to take 2.32 plus 2.34. Therefore, after getting the summation and divided it by the 2 means 2.325. You have to take the 2.32 plus 2.3. That means 2.325. That is the value. So after get 2.325, you have to take the summation of the two and divided it by the 2 to get the average, as we are not getting the 99% probability exactly, right? So that 2.325 is the Z value. And the standard deviation is 6. So 2.325, you have to multiply it by the 6 and at the expected time of the project, it is 64. So for the 2.325, you have to multiply it by the standard deviation of the project. As we are dividing here, you have to multiply that thing for the Z value, 6 multiply, and you have to add this expected value of the project is 64. As it is minus here, when we are going for the other side, you have to add this back. So it is 64. So the answer is 77.95 days. So after finding this for the 2 decimal place, you have to tell that approximately it is 78 days. Very good. Most of you have taken this answer and I think it is clear for you now, right? So those are the things actually that I can ask you from the exam paper, right? So that is for the second question. This is the end of the example number 2. So I have given you example number 3 as well as example number 4. Right. So in the example number 3, so one student has asked me whether I am giving activity on Arrow project network in the exam. Okay. So in the PERT, in the program evaluation review technique, we are basically using activity on Arrow approach because it is easier for us, right? So in the third question, you are asking to draw the activity on Arrow approach and calculate the expected time of the project and calculate standard deviation of the project, calculate the probability of the project if we are getting 55 days, that is the total schedule time. That is for the one. If you are taking 45 days as the schedule time, what is the probability, right? So in here, in the fourth question, it is asking 2 questions. And the fifth one is, if the probability is 92%, calculate the schedule time. So can you all try this out? Huh? So this is for the third example. And as the fourth example, I am asking you to calculate slack, right? You can see that in here also, in the third example, the question is given the predecessors as well. So therefore, you can easily draw the activity on arrow approach. And in the example number 4, you can see they are asking to calculate slack. And they are asking to calculate expected time, standard deviation, variance. So we are normally calculating in the PERT calculation now. And in addition to that, they are asking to calculate the early start, early finish, late start, late finish, all these things they are asking to calculate, right? So these are the things that they are asking to calculate. So the first of all, you have to draw for the example number 4, first you have to draw the activity on arrow approach, right? So I think you can now draw the activity on arrow approach easily, right? So after drawing the activity on arrow approach, you can actually, after drawing the activity on arrow approach, you have to calculate the expected time. Right after drawing the activity on arrow approach, you have to calculate the expected time for each of these activity, and after that you can find out early start, early finish, late start, late finish, as well as slack. So in the activity on arrow approach, we are basically calculating on the early start and what late finish. So in the activity on arrow approach, we are denoting it as a circle and we are calculating early start and late finish time, right? Therefore, the early start time you can directly taken from the project network as it is, right? And the late finish time also you can take it from the project network. But for the early finish time, in calculating early finish time, you can use this equation. Early finish time is equal to what? Early start time plus duration. But here we are taking the TE, right? Expected time duration. So you can take the TE. So after getting early start time plus the expected time, you can get the early finish time. So that is the equation you have to use when calculating early finish time. So what is the equation that you can use for the late start time? For the late start calculation, late start, from the late finish time, you can deduct the expected time, right? And for the slack is also not calculated when we are drawing the activity on arrow because we are drawing only a circle. So slack can be calculated by getting the difference between late start minus early start, right? So by using this equation, you can calculate these two values, early finish, late start, as well as slack. Early start and late finish are already there when we are calculating it for the activity on arrow approach. Right, so after that, you can calculate the standard deviation of the project. Remember that, so after drawing the activity on arrow approach and after calculating all this early start, early finish, like all these things, you can find out the critical path. So in the standard deviation of the project, you have to take variances of the critical path activity and get the square root out of that. Therefore, after calculating expected time, you have to calculate standard deviation for each of these activity, and then after you have to get the variance out of that. So after that, you can take the standard deviation after highlighting the critical activity and get the summation of the variance and take the square root out of that. Means you can get the answer for the standard deviation of the project. And nextly, the fourth question is calculate the probability of the project. If the 50 days, if the schedule time for the project is 50 days, what is the probability that you are going to finish that project? So if the schedule time is 56 days, what is the probability of finishing out that project within the 56 days? Right. So that's the last question I am asking. If the probability is 99%, what is the schedule time? Right. So these are the two questions that I want you to do as homework. So did you all clear about this? So optimistic means A, most probable means M, pessimistic means B. Clear. So we are meeting after the mid-semester exam, right? So week after week. So can you all do this thing and come to the class? මේ question දෙකම complete කරගෙන එන්න. මමත් question එක හදලා මමත් ඒ වෙලාවදී පොඩක් explain කරන එක විතරයි කරන්නේ. I am not going to explain it by step because I have now explained those things already. මම ඊළඟ mid එකෙන් පස්සේ එන සතියේදී මම මේ calculations ටික කරලා මම answer එක අරගෙන එන්නම්. හැබැයි මම එකිනෙකම explain කරන්න යන්නේ නැහැ because I want to start the next lesson as well, right? So I will take only half an hour and discuss these things. Therefore, please make sure to do this two example at home and please bring that answer. You are getting physical, no? Physical lectures after the mid-semester. Mid-semester can pass a physical ne. So shall I upload this answer to the LMS? Do I need to discuss this answer with you at the class? මම මේ දෙකට answers LMS එකට upload කරන්නද නැත්නම් class එකේදී discuss කරන්න ඕනද? So please do not come to the class by not doing this homework, right? Please ask others also to complete this example. All right, I will discuss in the classroom. So I will actually draw these things and come. That would be easier for me when explaining. Otherwise, it will take longer time to draw and explain those things. Right. So that's all for the today. And please make sure to complete this example number 3 and 4 and come to the class. So do you have any mid-semester exam for this semester? Yes. For what? Costing? No, you are not having costing, right? Tax. Right. So wish you all the very best for the mid-semester exam, and we will meet after the mid-semester exam. And please remember that your assignment deadline is I have extended up to Sunday 4 p.m. Please make sure to submit all your assignment within that deadline. I will not going to extend that deadline furthermore. And once the university is open for you, please make sure to submit all the assignment within the first day itself, right? mid semester එකෙන් පස්සේ ඔයගොල්ලන්ට කැම්පස් එකට එන්න පුළුවන් නේ. එතකොට පළවෙනි දවසේම ඔයගොල්ලෝ ඔයගොල්ලෝගේ assignment එක submit කරලා දෙන්න ඕනේ department එකට. හරිද? So after the mid semester exam I will give you the second assignment as well, right? So right, thank you very much for your feedback. So let's meet after the mid semester. I will wind up the today's session.